Please like, subscribe, and put on your notification. Thank you.
Hello everyone, welcome to Tutelage Educational Services. I am Simisola Akeju, a basic science teacher, and today I want to talk about the topic calculation of gravitational force. And before then, I want to give a brief introduction on what force is. What is force? If you check your dictionary, you see words like compel, impose, pressure, exertion, and so on. But in sciences generally, when we look at the word force, we want to consider two parameters, which are the mass of a particular body and the effect of the force. And when we talk about the mass of a particular body, we are talking about the quantity, the quantity of a material or the quantity of matter that makes up a particular body. Exactly. And also, I'll be moving forward to the types of forces. We have two types of force. We have the contact force and we have the non-contact force. For the non-contact force, we have gravitational force, we have magnetic force, we have electromagnetic force, and so on and so forth. So moving to today's topic, calculation on gravitational force. What is gravitational force? Gravitational force can also be defined or can also be called force of gravity. It is the force with which the earth attracts an object towards the center. And in other words, it is the force that pulls an object thrown up downward. That is, take for instance, when you throw a particular coin and when you throw an object up, the force that tends to pull that object down is what we call the force of gravity. Exactly. Now, another thing I want you to note about this gravitational force is that it is an invisible force. You cannot see it with the naked eyes, neither can you see it with the head of a microscope. So it is invisible. It's not something you can just see and then point at and say, oh, that's a gravitational force. So now we want to look at the calculation on gravitational force. Like I said before, that when we talk about force, we'll be considering two physical quantities, which are the mass of the body and the effect of the force. Now, and I said the effect of the force can be in form of change in shape of a body and then change in position. When I say the effect of the force can be in form of change in position, let's assume a particular driver is driving and then in the middle of the road, the car breaks down. What happens? And then he decides to call people to help him push the car forward. So people, in the course of pushing the car forward, you notice that the car tends to move from the position it was before to another position. So we can say, with the application of the force, there's a change in the position, which is the car moving from its initial position to another position. Now, we therefore say the formula for force is the product of mass and acceleration. That is, mass times acceleration will give you force, where the mass, the SI unit for mass, that is, mass is measured in kilogram, and the acceleration is measured in meter per second square. Therefore, you say force equals to kilogram meter per second square. Remember, this is a derived unit of force, but the SI unit of force is what? Is Newton. Force is measured in Newton. So that's that about force, because we'll be using this formula to get formula for gravitational force. That's why I have to introduce it first. Then, now, moving to the force of gravity. So, the formula for finding the force of gravity is also the same formula where we use for finding force. But in the case of force of gravity, we say force equals to mg, force equals to ma, where m is the mass of the body and a is the acceleration. But in the case of force of gravity, this a will be replaced with g, and therefore we say the force of gravity equals to mg, where m is still the mass, and then the g in this case now is the acceleration due to gravity. That is why it is represented as g. Remember, this is just a, which is acceleration, while this g is the acceleration due to gravity. And another thing about this G, acceleration due to gravity, is that it's a constant and the value is equals to 9.8 meter per second or 10 meter per second square. Exactly now. So let's try to look at an example before we move to the next one. Now calculate the gravitational force on a mass of 20 kilograms if the acceleration due to free fall under gravity is 10 meters per second. Now, one thing you have to note about this, when you are answering questions in physical science, you write out all the parameters given. What are the parameters? Those physical quantities you are given, like force, acceleration, mass, you write them out first so that you'll be able to tell what kind of formula to use. Now, we have, in the question, we've been given our mass to be 20 kg, and then we've been given our acceleration due to gravity, our G, acceleration due to gravity, to be 10 meters per second, so it's a constant. And so we are told to look for our force of gravity, which is denoted by letter F. So remember that force of gravity equals to mg. Therefore, we say F equals to the mass times the acceleration due to gravity, which is 10. Therefore, F equals to 20 times 10 is 200. Remember to always put the unit, the SI unit for force is Newton, so you put the capital letter ahead. So we have 200 Newton. Now, we also want to talk about something, that is the work done in moving a particular body, due to gravity. The work done. Now, in physical science, when we talk about the work done, we have to consider two things: the force and the distance moved. That is the force and distance moved. Take, for example, two different people standing, one carrying a stone. You know how heavy a stone is. One carrying a stone and then fixed at a particular position, while somebody else who is carrying just nylon is walking about. If I tell you that the person who carried nylon and then walked about has done much work than the other person who carried a very heavy stone but still in a particular position. Now, the person who carried a heavy stone and still in that particular position has done no work, because in physical sciences, when we talk about work done, you have to consider the distance moved irrespective of how heavy the load you are carrying is. You could imagine, if you have to weigh the mass of the stone and then the mass of the nylon, you should be able to tell the difference. You should know that the stone is much more heavier than the nylon. So the work done equals to the force and distance moved. That is a physical science. Now we therefore say work done equals to the product of force times the distance moved. Now remember that when we talk about force of gravity, we said force of gravity equals to mg. Therefore, you can easily substitute this mg in the equation. In this equation, work done equals to force times distance moved. Therefore, we have work done equals to where our force equals to mg. So instead of you just putting the force, you can easily put the mg times, we are talking about gravity now, so we replace this distance with height. We therefore have our h there. Then work done equals to mgh, where our m is the mass of the body, our g is the acceleration due to gravity, which is always a constant. Then our h equals the height. Exactly. So remember also that the formula for work done, equals to mgh. Then our SI units, that is work done, is measured in joules. The SI unit for work done is what? Is joules. Now we want to look at a question. We want to solve an example. Now, find the work done on a mass of 2 kilograms if it is raised up to a height of 10 meters, given that g is 10 meters per second squared. Remember the step we are to use. The first thing is that you write out all the parameters you are given. We've been given the mass of the body to be 2 kilograms. We've been given the height to be 10 meters. The acceleration due to gravity, which is always 10 meters per second squared. And then we'll be asked to look for the work done. So using the formula W equals to mgh, W equals to m, our mass, which is 2 kilograms, times our acceleration due to gravity, which is 10 meters per second squared, times our height, which is also 10 meters. W equals to 2 times 10, which is 20, times 10, 200. Remember to always put the units, which is in joules. So W equals to 200 joules. Thank you for watching, and I hope you liked it. I am Simsala Keju. For more of our videos, you can subscribe to our YouTube channel at Tutelage Educational Services. Thank you. Goodbye.